Sewage has entered Gauteng's river systems, impacting the province's water quality. This after it emerged that pipes were leaking into the same river in Johannesburg for nearly a week, on what's been blamed as an alleged blockage in October. Internationally renowned water expert Professor Anthony Turton joins us to discuss this. Prof, good evening. Lovely to speak to you. Let's talk about these leakages and the overview of the recent leaks in Johannesburg. What are your thoughts?
Good evening to the listeners. Well, these leaks are one of hundreds. I mean, it's and while this particular leak is getting attention in a particular geography at the moment, there are identical leaks happening in almost every town and city in South Africa at this point in time. It is a national pastime, I would say.
So, what are the primary causes of these sewage leaks into the rivers?
Well, sewage flows by gravity. That's the first thing that people need to understand. So because it flows by gravity, it's got large diameter pipes, and therefore it has to flow in a constant slope from a high ground to low ground. And at the end of the day, it tends to follow the natural drainage channels, which in other words, little rivers, streams, spraiter and stuff like that, you know. So your sewers generally follow a natural water course. And then because they flow by gravity by and large, there are some cases where it's pumped, but in most cases it's gravity fed. And the end of that journey ends up in a wastewater treatment works, which is invariably next to a river. And there the sewage is processed. It's processed to a very high standard, or it's designed to be processed to a high standard. And then that effluent is then discharged into the nearest river, from which it then flows down from that point, you know, however far it's going to flow, to the very, very next abstraction point where the next town or village or city gets its drinking water from. So that's the important thing that the public needs to understand, is that all of our sewage flows into our rivers, with the exception of a few sewage outfalls along the coast. Durban used to have, Cape Town has still got a couple of sewage outfalls going to the ocean, but for the rest, we produce 7 billion litres of sewage every day, 7 billion litres every day, and the vast majority of that goes directly into our rivers, and about 40% of it is treated properly. About 60% of it is treated either partially or untreated at all, goes straight back into our rivers. So, in other words, work it out, 60% of 7 billion litres. Just to put into context the particular spill that you're referring to now, you'll see that spill that you're referring to is actually quite a small spill compared to the overall scheme of things.
So let's talk about capacity to deal with the 7 billion litres. I mean, obviously, if so much of it is going into rivers, then we have no capacity.
Well, that's a very, very good point, because there are two models that engineers use. So you've got to make a decision one way or the other. And you can either go the direct reuse model or the indirect reuse model. So the direct reuse model means that you put your sewage into a sewage works, you then treat it, and then coming out the other side, you actually get drinking water coming out the other side. That's a direct reuse model, and places that use that, for example, are Singapore. They've got a direct reuse model. Windhoek in Namibia has got a direct reuse model, and Perth in Western Australia, for example, has got a direct reuse model. And then the rest of the world has generally followed an indirect reuse model. What they do is they discharge the effluent back into the river, and then it then goes down the river stream, and eventually gets taken out the river again to be treated into drinking water. Now, once you understand this, the fact that our entire system is designed this way, we have over 1,000 different wastewater plants in the country, and we have almost as many water treatment plants. So we've got plus minus, if you can add them up, round out the numbers, about 2,000 plants, roughly half of them doing sewage and the other half roughly doing drinking water. But they're separate. They're separated geographically by a piece of river. And now once you understand that, you then start hopefully understanding what the difference between the blue drop and green drop report is, because we often hear reference to the blue and green drop. Now, the green drop reporting standard is the reporting standard for the effluent that comes out of the end of the pipe at the wastewater works, where it's discharged into the river. Now, that has to be at an exceptionally high quality. Why? It It has to come out at almost drinking quality standard for the simple reason that it's going to become drinking water after a short journey in the river. So we can't be happy with, for example, a 60% compliance with wastewater, because that implies that we've got 40% non-compliance, which of course is a disastrous situation when you're looking at the numbers involved. So once the listener can understand that these basic design factors, we can get into other details underneath it if you want to go into greater detail. But that's what the sort of average Joe Bloggs in the street needs to understand, what I've just said to you now.
So to what extent do factors like blockages, illegal mining activities, or inadequate maintenance contribute to some of these incidents?
Yes, so let's sort of look at these things. So what is a blockage? Okay, so the blockage, firstly, because everything goes down the sewers, one of the things that goes down the sewer is fats, oils, and greases, because very often the sewer drains the kitchen. And if you wash your dirty dishes or something like that, then fat, oil, and grease gets congealed, gets washed out in the washing machine, but ultimately it ends up in the sewer, and that starts congealing. So you get these great big balls of fat that go floating down these big sewers, and they start coating the side of the pipes, and that becomes a huge problem. That's got to get cleaned out on a regular basis. So that's the first thing. Then the second thing, that what we're seeing now is the emergence of a criminal syndicate that deliberately sabotages the sewers. They put foreign objects in it. By foreign object, I'm talking about a rock. I'm talking about a tire. I'm talking about something that is deliberately designed to obstruct the flow. And why do they do this? They do this because they want to force the flow of the sewage to the surface in order to create an inconvenience for the people in the area. Why do they do that? Because they then go and get a contract. They get a tender. They get a contract to go and rent out a sewage pump. So they create the problem, and then they sell the solution back in. And there's some litigation currently before the courts in South Africa on just this matter at the moment. So this is it's a self-destruct thing, but that is what is happening. Then, of course, there's a third component. There's mentioned made of Zama miners. Well, Zama miners, you find them all over the show. And I've mentioned earlier on that your sewers tend to follow river courses. And, of course, associated with river courses, you get wetlands. And in the case of the Witwatersrand goldfields, the Gauteng area, all of those wetlands have drained at some point in time off a mine tailings dam, a gold mine tailings dam, a mine dump. And therefore, they've all got some trace metals in them, heavy metals ranging from uranium. All of our wetlands have got uranium in it. All of our wetlands have got some kind of nickel and cadmium and all kinds of exotic metals, and of course small quantities of gold as well. So you find that some people are trying to reprocess this, which is an illegal activity. And there's in fact even a group of people that I know of that actually go diving. They go into the water in the sewer itself, and they go diving for artifacts. So, for example, watches and or things of jewelry, etc., that might have been flushed down the toilet inadvertently or something of that nature. So that actually happens as well. So these are all disruptive activities, and I mean it's horrific to think of someone actually mining a sewer, but this is what they are doing in some places, and all of this ultimately disrupts the flow of the of very, very harmful waste material, because the system is engineered to keep that away from human contact, because it's highly pathogenic. In other words, it's got lots of diseases in it, and it's also got lots of nasty chemicals and stuff in it, which are not good for human health at all. So that's why these systems have to be maintained. And, of course, if they compromise, then there's a lot of unintended consequences, and that's what we started to see now in South Africa. Across the entire country, we're seeing the unintended consequences of allowing our sewage infrastructure to fall into such a really bad state of disrepair.
Now, a few months ago, we talked about the state of repair or disrepair of the various water systems across Gauteng. And one of the challenges that was raised was that the population has grown astronomically over the last 15, 20 years. But there hasn't been a corresponding impact or development of the infrastructure. Is this an issue? Is this one of the problems that we're facing in Joburg and Greater Joburg?
Without any question of doubt. I recently read some numbers that suggest that the urban population in South Africa has doubled since 1994. and there's absolutely been no infrastructure upgrade. I know of very, very little infrastructure upgrade in any of the major or even in the smaller towns in South Africa. So we can say that the population has doubled through natural demographic processes. We've also had on top of that the inward migration of people from rural to urban areas. So it's very possible that in some of the urban areas we've had a more than doubling of the population that has to be serviced. And in that period of time, I don't know of any cases where the infrastructure has been upgraded, and in very few cases where it's been properly maintained. So what you see now is infrastructure that was built 25, 30 years ago, that was fortunately built to a very high standard then, but it's all slowly falling over one by one now. And many other things have happened in the interim now, most notably the loss of our institutions. The institutions that have to make decisions about funding, have to make decisions about what maintenance must be done and which pipes must be replaced, and the sequencing of all of that. And these are very complicated engineering decisions that must be made. Those institutions, in many, many cases, have been altered and restructured out of functional existence. So therefore, that's what we're now seeing. The chickens are coming home to roost, and that is why, just ironically, South Africa has the bizarre situation today where the biggest single polluter of water in the country is the state, and the state, by virtue of the authority in the National Water Act given to the state, where water was nationalized in 1994, the state became the sole custodian of water on behalf of the people. Well, they are the biggest single polluter of water. So, if you look at it from that perspective, we're talking about an absolute dismal failure of the management of water at that level. And we're not going to be able to carry on like this for too much longer without some very, very dire unintended consequences.
Well, you talk about this, and South Africa is celebrating 30 years of democracy this very year, where we talk about 7 billion litres of sewage flowing every single day. So let's talk about, as an international expert, let's talk about what other countries have done to deal with a similar situation, and what are the options that are available to South Africa.
Yes, that's a great question. So, wherever you go in the world, there's generally a crisis of this nature. In fact, I'll just tell you a story. I found myself once in a canoe, believe it or not, on a river outside Washington, D.C. with a NASA rocket scientist of all people. And we were canoeing along there, and he said to me that the Potomac River, they've got a problem there because they can't upgrade their sewage. And I said, are you telling me now that here at Washington, D.C., the so-called center of the free world, in some people's worldview, you can't upgrade your wastewater works? He said, there's all kinds of pushback and cost and this, and people don't want it, and blah, blah, blah. So from that, we can accept that it is a universal problem. If you listen to any of the daily media broadcasts coming out of Britain, for example, you'll see that the British are also in an appalling situation where they discharge their sewage into the rivers. Some of the better water management people, the Australians, for example, are extremely progressive in the way that they manage their water. I do a lot of traveling to Western Australia. I was there just about 6 weeks ago in my last recent trip there. And what they do there is they recover all of their water from sewage. It's a huge recovery plant. They take it to the highest level of potable quality. And then they've added an additional innovation. Instead of supplying it straight back into the drinking water stream like they do in Windhoek, for example, what the Australians are doing in Perth is they store it underground in a great big aquifer. In other words, they inject it down injection wells, and they store it for a number of years underground. So they call that water banking. And this is a very smart move because one of the big things that's happening in the water sector at the moment globally, besides the fact that population growth all over the world is now starting to deplete your freshwater resources. So it's not just but one of the big issues as well, of course, is climate change. And with climate change, what you particularly have is elevated temperatures and elevated losses of water off open water bodies, so dams. Dams lose huge amounts of water. Now, I can give you some of the numbers if you want to, but these numbers are staggering. And, of course, as the dams end up with losing water. They become slightly more saline because whatever's left behind stays behind in the water. But more importantly, they become a little bit warmer. And now if we can think of a situation like in South Africa, where you've got warm water, water that's warming up in dams because of what I've explained, at the same time that you've got increased flows of sewage nutrients into the water, then you start getting this blue-green algae. We've got in the Vaal River now, we've got it in the Paardebeesport Dam, we've got it in the Harip Dam. So this is becoming a huge national problem. And of course, that's got all sorts of consequences because that blue-green algae is toxic.
Prof, that's where we leave it for this evening. Appreciate your time and thank you for unpacking those issues for us. Professor Anthony Turton, Centre for Environmental Management to the University of Free State.